Hello, we are Nicolás, Sebastián, Juan David, Santiago, and Valeria, and today we are going to present practice 1 of automation, the design of an automated productive process using Fisher technique and RoboPro software. Our case study is an automated bakery where the entire production flow of a cake is simulated, from the rush stakes until it reaches the baking area.
Our first objective was to design and program an automated production process using Fisher technique and RoboPro. This allowed us to replicate a real production system in a smaller, controlled environment. The second objective was to identify the inputs, outputs, and key stages in the process in order to understand how the system works step by step. Then we compared the automated version of the process with the manual one, highlighting the main differences in effort, precision, and repairability. Finally, we measured and optimized the cycle time, which helped us evaluate the system's efficiency and look for possible improvements.
The process begins with initial placement, when the raw cake is placed onto the input tray. A sensor detects it and activates the transport system moving into the oven. Inside the oven, the tray stops and the baking process begins lasting for the required amount of time. After baking is complete, the tray is moved back and a suction arm lifts the cake and transfers it onto a routing table. The routing table carries the cake to the coating station where a saw divides it into uniform portions. Next, the table routes again to the ejecting station where a pneumatic cylinder pushes the cake portions onto a conveyor belt. And finally, the conveyor belt transports the portions to a baking area. A sensor confirms the arrival and the system resets to start a new cycle. Manually, the process can be also performed, but it requires much more effort from the operator. First, the worker places the tray inside the oven, close the door, and set the timer. This takes about 25 seconds. The baking itself lasts approx 15 minutes. After baking, the worker removes the tray, places the cake on a table, and rotates it manually, and cut it into pieces using a knife or a pastry guillotine. This step takes about 35 seconds. Finally, the portions are pushed manually onto the output tray and carried on the baking area, which it takes around 20 seconds. In total, the manual cycle time is about 70 minutes per cake, while the automatic system requires a similar time because of a baking process. It provides much greater precision, consistency, and reduces the physical effort.
So now I will explain the inputs and output. First, it's important to mention that our station has two models, one master and one slave. Therefore, some inputs and outputs are either slaves or masters. Now we will see the inputs related to sensors and limit switches. This input detects position, presence, and states in the process. They provide the necessary signals to control the sequence of operation. In this case, we have 7 limit switches, 4 masters and 3 slaves. The other sensors in this section are the phototransistors. The one on the conveyor belt is master, and the one on the oven tray is slave. On the other hand, we have the outputs related with motors. These motors generate the mechanical movement of the system, such as rotation, transport, tray movement, and suction handling. In this case, there are 3 master motors, which are the table motor, the conveyor belt motor, and the saw motor. There are 2 slave motors, the one for the oven tray and the one for the suction unit. On the other way, we have the outputs related with valves and pneumatic electric actuators. These outputs control pneumatic and electric devices that allow the system to perform auxiliary but essential actions, such as product ejection, oven door operation, and heating. In this case, there are 2 master actuators, the ejection valve and the compressor, and 4 slave actuators, which are the vacuum valve, the lowering valve for the suction device, the oven door valve, and the oven light. Now, the program works as an infinite loop because once the sequence finishes with the product ejection and transport, the flow automatically returns to the initial position without a stop command. It is automated because each step is triggered by sensors and limit switches that confirm the previous action, activating the corresponding motors, valves, or actuators without human intervention.
With this, we conclude. Thank you for listening.